As we move into the diaphysis area, the first we're gonna encounter the periosteum, which is a dense layer of vascular connective tissue enveloping the bones except at the surface of the joint. We use the toilet paper roll since it's thin and it's compact. And then moving on, it's the endosteum, which is the thin layer of vascular membrane of connective tissue that lines the inner surface of bony tissue that forms the medullary cavity of the long bones. We use the construction paper. And on that surface, we have the perforating fibers, which are a matrix of connective tissue consisting bundle of the strong collagen fibers that connect the periosteum to the bones. And for the perforating fiber, we use elastic fibers, which is elastic band because it's elastic. And in the inside, we have the compact bones. The compact bones forms a shell around the tensorless bones and is the primary component of the long bones of the arm and the leg and other bones, where its greater strength and rigidity are needed. We use the cotton ball since it's white and it has gaps in between, like a small gaps, so it kind of resembles the compact bone because it's pretty dense. And inside, we got the yellow bone marrow, which is the area of it's like a storage for fats. So let's say when you need energy source, just take the fat cells inside the yellow bone marrow and convert it into the energy. And for the yellow bone marrow, we use the yellow pencil for its color. So yeah. So now we're gonna move into the inside of the compact bones.
Osteon is a structural unit of the compact bone, and the way we drew it out was with construction paper and pointing out the black little dots that are right next to the peritoneum and the yellow bone marrow. The canaliculi is the hair-like canals that connect two lacunae to each other to the central canal. Where it is located is between the Haversian canal and the osteoblast. And what I did to mark it is a little canal or a little line on the empty toilet paper roll to the Haversian canal marked. The Leucane is occupied at the junction of the lamellae. It's also in between the osteoblast and the Haversian canal. It is also marked on the empty toilet paper roll on the side where it is black near the little canal. The Haversian canal contains small blood vessels and nerve fibers, and also serves the needs of ostean cells. What I used as a diagram was the empty toilet paper roll, and I marked a canal that is scratched with black. The osteoblast forms the bone encasing in a bone collar, and the diagram I used is on the same place where the Haversian canal and the canaliculi are located, and it is the black bob with also a black dot in the middle. Also in the same place is the lamellae, which is the little plates of the compact bone that forms a pattern with the collagen fibers, and it's also located directly above the osteoblast and outside of the little canal. Lastly, we have the osteoclast, which is located on the left of our bone diagram. The osteoclast breaks down the bone and the hyaline cartilage, and as a diagram, it's black little dots breaking down and separating. Next up, we're going to move on to the proxial epiphysis.
The nutrient artery, usually accompanied by one or two veins, enters the bone through the nutrient foramen, runs obliquely through the cortex, sending branches upward and downward to the bone marrow, delivering nutrients to the bone. To represent the nutrient artery, we used red pipe cleaner. Located in the main shaft of a long bone, the medullary cavity has walls composed of spongy bone and is lined with a thin vascular membrane holding the bone marrow inside the bone. To represent the medullary cavity, we used cotton balls, reflecting their density. Consisting of plates and bars of bone forming a spongy texture, spongy bone is ideal for making and storing bone marrow. To represent the spongy bone, we drew brown spots because spongy bone looks like spots.